Hey everybody, I want to talk through the lab we're going to do for this week. So this is our Dosage Measurement Lab PDF. This is found in our Blackboard course. If you go into the labs folder, you can download this PDF, and here is what it looks like. So I'm going to walk you through a couple of things because we're only going to have an hour together in lab since we're doing the Group A, Group B stuff. So please take note of these things, and then you will input all your answers into the corresponding Blackboard assignment when you're done. A lot of people have trouble on the post-lab questions with this lab, so that's why I'm going to walk through some things ahead of time, and then I'm probably going to have some time Friday of this week, maybe possibly Monday of next week, and give you guys extra time to ask me questions if you have trouble calculating or working those problems. So first off, I'm going to read this little paragraph. It says, a supplement company is selling an all-natural Toxic Cleanse product in retail stores nationwide. I'm going to highlight this. The dosage on the bottle is listed as take 1.5 teaspoons Toxic Cleanse daily as needed. So I'm going to write this over here, or it's down here. 1 dose equals 1.5 because it's 1.5 teaspoon. TSP, I'll abbreviate. All right, so that is a conversion factor relating a dose and 1.5. You might see the word dose later on. So again, that is equivalent to 1.5 teaspoons, and that's where we get that information. All right, let's keep reading. The company isolated the product from the exoskeleton of an insect from the Amazon rainforest. Cool. The suspected active ingredient is structurally identical to a drug the FDA rejected during clinical trials. That sounds like not good information. Why are we marketing this drug if it's identical to a drug that's already been rejected? I don't know. We're going to figure this out. During these trials, the ED50 and LD50 were determined. Okay, so what is an ED50 and an LD50? ED50 stands for the effective dose. How much drug do you have to take? How much any drug do you have to take for the drug to be effective in your body based on your weight? Okay, LD50 is how much drug would you have to take for that drug to be lethal to your body at your weight. Okay, so these are relationships. They're dependent on body weight. So that's why you see, if you look down here where I'm putting this star, the ED50 for this drug in particular is for 6 milligrams of the drug per kilogram of body weight. Okay, so for example, if someone weighs 100 pounds, we could calculate how many milligrams of drug they would need to take for that drug to be effective in their body. First, we would need to convert pounds to kg. Okay, so if we do that and we multiply, we say for every 1 pound, it is 0.454 kg, then we get 45.4 kilograms, okay? So that's the equivalent weight in kilograms. So now we could take this relationship and say, okay, we got 45.4 kilogram person, that's how much they weigh. For every 1 kg, it's 6 milligrams of the drug will be effective. And so total, for their total weight, 6, I actually have to calculate this, 6 times 45.4 is 272.4 milligrams of the drug. Okay, so for a 100-pound person, 272 milligrams would be effective. Okay, you could also calculate this for the lethal, for a 100-pound person, how much of the drug would be lethal. Okay, you would just use this relationship and do the exact same calculation, but instead of plugging in the ED50 right here, you would plug in the LD50. You could calculate how many milligrams of the drug would be lethal to a 100-pound person. This is not part of the lab. I'm just showing you how these relationships and how these conversions will work later on, okay? So remember, I'm going to erase for just a second, that these right here are relationships. They're relating milligrams of drug to kilogram of body weight, and you will need to use them in the post-lab questions below. Okay, you also have some other really important relationships right here, okay? So you have the pounds to kilogram conversion that I just used in my example problem. Then you have the density of water. Why do we have that? It's 1 gram per milliliter. That's because our, quote, toxic cleanse in lab is just water. It's just water with food coloring. Sorry if I'm disappointing you. But you will have to convert between mass and volume for this particular substance, and because our substance is water, we're pretending it's a toxic cleanse, you're going to use the density of water to convert between grams and milliliters later on. All right, and then again, the last one you have is that 1 teaspoon equals 5 milliliters. Okay, so if we take 2 doses, if you give somebody 2 doses, you could calculate how many milliliters that would be. Because you know 1 dose is 1.5 teaspoons and 1 teaspoon is 5 milliliters. You could use these relationships, okay? You would have to use both of these, the dose to teaspoon and then the teaspoon to milliliters right here to calculate if you gave somebody 2 doses, so on and so forth. I'm just showing you have these relationships and you will need to use them throughout the lab, okay? This walks you through the equipment. So the first thing you're going to do when you walk into lab, I'm probably going to talk for just a minute to all the students and then I'll start letting you go. You're going to weigh an empty weigh boat. We're going to use weigh boats. Weigh an empty weigh boat. The balances in the labs have lids, okay? Remove the lid, the metal lid, from the balance first before you weigh anything, okay? And then you will report all the decimal places that the balance gives you. I think there's 3 decimal places that you'll report. But you're going to do that with 3 weigh boats, okay? This walks you through those instructions. Then we are going to use a spoon, a medicine cup, and a syringe. Okay, these are common household things that we use to give our children medicine. I used a syringe this morning to give my children some medicine, okay? But I also use medicine cups. We also have spoons. We're going to see how accurate these things are and then how much variation there can be with these particular instruments, okay? So please follow these instructions carefully. You'll measure out a dose of your toxic cleanse using a spoon, a med cup, and a syringe. You'll transfer those into the weigh boat that you've already got the mass of. And then you'll get the mass of the dose of toxic cleanse. And you're going to report all this stuff right here on your data sheets, okay? So this is section 3 data sheet. So this will be, you'll report the mass of the empty weigh boat 1, 2, and 3. You'll do that on all of these tables, okay? Note that these tables are for particular instruments: spoon, medicine cup table, syringe table. And then you will go on getting the mass of the dose plus the instrument, or from what that instrument you used. You'll report the mass of that, and then you'll subtract. You'll do the mass of the empty weigh boat. You'll subtract that out of the mass of the weigh boat and the dose, and you'll report these numbers all here. Then what you're going to have to show me before you leave is the average mass and then the range for each of these things. So these 6 measurements that I'm highlighting right here, the average and the range for each of these instruments, you're going to have to show me this before you head out of lab, okay? So once you finish those things, we'll see how much time we have left. If you finish all of this, your data sheet, getting all your masses, calculating the average and the range, and you have extra time, you can start working on the results section, okay? So this is where we're going to start answering some questions. Notice that I've said for these first 2 problems, see the conversion factors on page 1. They will help you calculate numbers 1 and 2 here. We're not going to be doing number 3, so I've marked this table out, so mark that out on your PDF. And then you can start with the number 4 and the going deeper questions, okay? These going deeper questions are the ones that are challenging. But again, I will be available throughout the week to help you guys answer questions with these. The last thing I want to point out, though, is number 8. Number 8 asks you to go to your data table, and get your single largest variation in volume. However, I have given you a number here I want you to use, okay? So mark this out. Do not go to your data table and get the largest variation. I want you to use 1.054 milliliters. And pretend that that is your largest variation in volume. And I want you to calculate, okay, whatever this question's asking you, using this initial number, all right? That's the only change and edit that I think I made to this particular lab. And then once you're done, you'll, again, put all your answers into Blackboard and go from there. So this is going to be due September 13th, which is next Monday. I'm giving you guys some extra time to work over this. And I will see you guys in lab. Remember to wear the appropriate clothing.